All right, guess give everybody another minute or so to get in here. So I'm just leaving that note in the chat for anybody else who comes in. Yes, this is our last official Zoom. And I will be available next week if you need to schedule one for office hours or something like that. All right. So should be enough time for everyone who's coming today. So yeah, today is just all about seeing what you guys want to know about, what you guys want to discuss, or you know, whatever y'all need. So test 4 is up, but I am still working on the final. Lots of silliness going on. So yeah. What you got?
Could you briefly go over factoring polynomials?
Factoring polynomials. All right. So the general form is like this. So this is the kind you'll see most. But
is this our last Zoom?
I'm sorry?
Is this our last Zoom?
Yeah, I thought I answered that.
I had lost connection.
Oh, okay. Yeah, so this is our last official Zoom, but I will still be available next week if you need to schedule one to go over something. But yeah, this is our last class meeting. So in general, they'll look something like this, and we need to factor this down into something that is more useful. So the long version, I guess, that covers every possibility looks like this. Sorry, this thing's wobbling. So this is the whole point, is we need to take something that looks like this, turn it into something that looks like that. And what we basically need to do is solve three smaller equations, because we can't really do much just directly with that. So we take this first coefficient, and that equals a times little a times b. B equals, this is the involved one, a times n, b times m, and c is m times n. So this is the long and short of it, of factoring polynomials, or at least of quadratics. So we didn't really get much into higher order stuff, which is, fine. But we did look at these a good bit. And it's all based on this idea of working backwards from multiplying a binomial. So the first step is usually A. You list out all the factors of big A. You know that A and B have to be one of those sets of factors. You do the same thing with C. And then B is where you fit them all together. So if you like understanding one basic concept very well, and just applying it over and over and over, then factoring any quadratic can be done through this. So it's a pretty good place to start. The other option is, you have to understand more the math theory, and some people are good at that and they like that. And they can kind of change how they factor things depending on the situation. And for people who are comfortable with it, that saves time. But this method works for any quadratic that can be factored, I guess is the correct way to put that. So, all right. As far as exactly what you're looking for, are you looking to work one of these out? Are you looking to, what are you, what would you like to go over?
I guess the negative aspect of it.
What do you mean, the negative aspect?
Like, if the numbers are negative, because doesn't the rules change a little bit?
Okay. So there's nothing in here that says that any of these things aren't negative. And that's why we write it this way, is because if one of these things is negative, the negative is stored inside the letter. So capital B could be -6, but we still write it like this, because then these still hold true. So let's throw one in that is negative. Let's see. 2x squared minus I don't know, 6. So this would be minus 4. Okay. So what is capital A? What is capital A?
Two.
What?
2.
2. Capital B?
-4.
-4. And capital C?
-6.
-6. All right. So what are the factors of 2?
1 and 2.
1 and 2. Okay. What are the factors of -6? What are the factors of 6? First off.
1 and 6 and 3 and 2.
All right. What we do for the negative is we say one of these is positive and one of them is negative. Because we don't know which one yet. But if this was +6, then either these are both positive or both negative. Because if you multiply 2 negatives together, you get a positive. But since it's negative, that means one is negative and one is positive. Okay, so now we have to fit them together down here. So we know, or I guess right here. So -4 is going to be something times something plus something times something. Okay, so because this is negative, the bigger of these two things is going to be negative. And we can go ahead and put in our numbers up here, 1 and 2, because there's no options. So now we have to figure out down here what is going to be what. So we could try like 1 and -6. So this is 1 minus 12. That's not right. So we could try -6 and 1, which is -6 plus 2. Right?
Yeah.
Okay, what's -6 plus 2?
-4.
-4. So that means that this is correct. And when we factor it, we have 2x minus 6. And you don't have to put the 1, but I will. 1x plus 1. Okay. So you take the numbers that are up here and you put them in down here. And that is factored. So there are some things that you can do to often make your life easier. And one of those comes up here. So starting back over for a second, what is something that you might notice about these three things? So all three of these are divisible by 2. So you can take a 2 out of each of these, and then you have 2 times x squared minus 2x minus 3. And this is much easier to factor because we know that this can only be 1 and 1 for this one. And what that does to this is it makes it just this number plus this number. So what two numbers multiply together to give you -3?
One and three, but one of them's negative.
Yeah, and since this is -2, then the bigger one is negative. So x minus 3 and x plus 1. So, like I said at the beginning, this process will work every time, but you can simplify things and make your job a little bit easier. And this is true, across the board. If you simplify, often it makes things easier. So if we pull out that greatest common factor, it made the thing a little bit easier. But you get the same answer because if you multiply this 2 back in, you get 2x minus 6. So it's the same answer, just looks a little bit different. So either way is fine. It's just about which one you are most comfortable with. All right. Good questions. What else? What else? Nothing.
What were the fractions we did?
I'm sorry?
Didn't we do something with fractions?
You talking about rational equations?
Yeah.
Yeah. So a rational equation is one that has a variable in the bottom. So like 1 over x plus 1 over, I don't know, x minus 2, we'll just say equals 3. So one of the first things that you're going to try to do is you try to turn it into a polynomial, okay? And we can kind of do this in a way that is similar to just how we deal with fractions in general. What do we do when we're adding fractions?
Then we change the denominator.
Yep, we find the least common denominator. And this isn't always the best, simplest way to do it, but it is always a way to do it. One thing you could do is multiply everything by each denominator, okay? So what is this, guys? What is this fraction's denominator? It's not, I mean, it seems like a trick question, but it's not.
X.
X. So we're multiplying this whole thing by all of the denominators. So X. And what is the second one denominator?
X minus 2.
X minus 2. And then this denominator is actually just 1. But, I mean, that's just an extra step. We don't really have to worry about that. So if you multiply everything by x minus 2 times x, this thing becomes x minus 2. That's it. This becomes x. And this becomes x times x minus 2. Okay. So we have created a polynomial. So once we multiply this out, this is x squared minus 2x. And then you want to put all of the everything on the same side. So we're going to pull everything over to here. So this becomes 0 equals x squared minus 2x minus x plus 2 minus x, which equals x squared minus 4x plus 2. Yeah. So now we've turned this into a quadratic. So we can now solve for x in this case. The one caveat that's kind of different is in this step, you have to add a little note to yourself that says that the things that you are multiplying cannot be 0. Or said another way, none of the denominators in the original equation can equal 0. So when you do this step, put a star by it. X minus 2 can't equal 0, and x can't equal 0. So if you get to the end and your solution is that x equals 0 or x minus 2 equals 0, then you throw that solution away. All right, good questions. What else you got?
Yeah, that's all I can think of.
That's it. Anything newer? So like I said, apologize for the delays, getting hammered with paperwork, and your final will be going up. I'm running through it. I've been running through it this morning. So it should be going up soon. And if you are not a senior, then you will have until Tuesday at midnight to do it. So yeah. All right. Let's keep this going though. I don't want to leave anybody in the dust.
I guess we can work on graphing.
All right, graphing, good idea. Okay. Let's do. So I want you to find the equation for this, for the line that intersects these 2 points. So what is the general form for the equation of a line? General form for a line.
Y equals mx plus b.
Y equals mx plus b. Oh no, that's not good. All right. So what we need to find is M and B. You're given 2 points like this. It's usually best to start with M. How do you find M? What is M? So in the interest of time, M is the slope. So the slope is the change in the y over the change in the x. How much does the y variable or y component change from this point to this point? What do you have to do to -5 to make it +10?
Times it by -2.
What?
You said -5 and turn it into +10.
How do you go from -5 to 10? How far do you have to move?
Um, like 15.
What?
Isn't it like 15 or so?
It's 15. To go from 2 to 6, how far do you have to move?
Or
4. So at this point, you would simplify that down if you can, but you can't. So 15 over 4. The next thing you do is you pick one of the points and you plug in x, y, and m to this equation. So we're just going to use this one. So that is -5 equals 15 over 4 times 2 plus b. Well, pull this over. Well, first of all, what is 2 times 15 over 4?
that'd be like 30 over 4.
Or 15 over 2? So -5 minus 15 over 2 equals b. -5 is actually -10 over 2 minus 15 over 2 equals -25 over 2. So 15 over 4, -25 over 2. So nothing real wild going on. It's just basics. Like 2 basic rules is remember what the slope is, how to find it. It's the change in y divided by the change in x. And then for the last part, all you do is you plug that back in to the original relationship, because the original relationship is based on the idea that all of the points all of the points on the line, which includes these two, you should be able to plug them in, and they should make sense in that equation. So you can use them to help you solve that equation. All right. Any last minute questions?
No.
All set. Well, like I said, we'll have my normal office hours for today, and then next week, definitely Monday and Tuesday, I will be in the sitting in the office like all day. So email me, send me something on Discord. Let me know what I can do. I'm happy to try. This also goes for taking your test, because I won't be there in person, and it is still timed. So if you think that you might have questions or something like that, I highly suggest you do your test while I'm in office hours. That way you can jump on and ask for help if you need it. So thanks for for tuning in, y'all. Appreciate you guys sticking with me over Zoom. And if you guys need anything, just give me a shout and I will do what I can.